All right. Section 3 of Chapter 1 deals with something called midpoints and the distance formula. And I kind of introduced to you the distance formula in Section 1 and told you would be using it. But what I want you to do right away is I want you to take a scrap piece of paper and draw an A in the top left corner and a B in the top right corner. And I know that might take a little while. After you do that, draw a line that connects the two, as straight of a line as possible. I mean, it doesn't have to be perfect. Just draw a line, and you can see that on step 2, that's what I've done here. Then what I want you to do is fold your paper over, hot dog style, of course, so you get a crease going down the center that connects A and B. Now, you can have the edges of the paper touching, the A and the B touching. It really doesn't matter. But what I want you to notice is I want you to notice where the crease crosses that line that you drew between, or the line segment AB. I want you to put a dot there and put an M right below it. So you labeled it. Wherever that line crosses line AB or line segment AB, put a dot and then label it point M. Now I want you to think about these two questions. What do you notice about the fold in reference to line segment AB? What did it do to line segment AB? And I hope that you understand that it cut it in half. And then I want you to note what I want you to notice about a point M is halfway between A and B. And we're going to talk a little bit more about that right now. Two more definitions that you're going to need to know are midpoint. And a midpoint is the point on a segment that divides the segment into two equal halves, or two congruent segments. For example, M is our midpoint. It is halfway between A and B. It cuts line segment AB into two equal halves. We could say that AM, which is this side, and MB, which is this side, are equal, because both of those are half of the total. Okay? Half this, they're equal. Then we have something called a segment bisector. And a segment bisector is a point, a ray, a line segment, or a plane that intersects a segment at its midpoint. The little crease that we drew, or the fold in your paper, okay, that connects point M and AB. That line actually divides AB into two halves. So the line, that fold that we made, would be the segment bisector. It bisected, or it cut into half. Bisect, by the way, means cut into half. It bisected line segment AB. Well, if it bisected the segment, it's the segment bisector. What I want you to notice is that both the midpoint and the segment bisectors bisect a segment. Both of them cut the segment into two equal halves. Whether it's a point or whether it's a fold, it cuts the line segment into two equal halves. In example 1, point M is the midpoint of VW. What does that tell you about VM and MW? Because M is halfway in between VW, or V and W, what does that make point M? Well, it makes M the midpoint. But what else I want you to notice is, I want you to notice that they're equal. This segment and this segment are equal. So we could actually write VM equals MW, because this segment and this segment are exactly half. This is one half of the whole. This is one half of the whole. If they're both one half, then they're equal. Well, now we can actually use that. We could use that information of setting them equal to find out what their total lengths are. Well, if VM equals 4x minus 1, we can replace it with 4x minus 1. Just like when we did the segment addition postulate, we said that this segment plus this segment equals the whole, and we just replaced it. We replaced the different values with whatever they were. I can say that Vm equals 4x minus 1. I can say that Mw equals 3x plus 1, so I can just replace them over here in this sentence, or in my equation. And now I can use my math skills, or my algebra skills, to solve this. The first thing I want to do is get all my x's on one side. Now, I like getting them all on the left. It really doesn't matter, whichever way you feel comfortable doing it. So if I want to move this 3x over here, how can I do that? Right now, 3x is being added to 3. If I want to undo that addition, I need to do the opposite, which is subtraction. But what I do to one side, I have to do the other. So I'm going to subtract 3x from both sides. And look, I moved it to the other side. I can drop everything else down that I didn't use, like the 3 equals -1. And now I simplify. 4x minus 3x. If I have 4 of something and I take away 3 of that something, how many somethings do I have left? I only have 1. Now, I want to keep going. I want to solve for x. Because once I have x, I can plug it back in and find out what both of these line segments equal. So now I want to find out what just x equals, which means I need to get rid of this -1. How do you get rid of a negative? You add a positive. So I'm going to add 1 to both sides. Cancels out on this side, and I get 1x equals 4. Well, if I divide both sides by 1, I get x equals 4, which is what I was looking for. Get it? X equals 4, that's what I was looking for. Anyway, now that I solve for x, I can plug x back in over here and say 4 times 4 minus 1, 3 times 4 plus 3, and I can actually find out what Vm and what Mw are as far as what their total lengths are. Well, 4 times 4 is 16 minus 1. 16 minus 1 is 15. I know that Vm is 15. 3 times 4 is 12 plus 3. 12 plus 3 is 15. I know that Mw is 15. Now, I already knew that they were both equal because they told me m is the midpoint. If m is the midpoint, then these two segments have to be equal. This just helped me prove it. Look at what we did. We knew that they were equal, so we actually set them equal. We said Vm equals Mw. Then I replaced both segments with the information they told me. They told me that Vm is 4x minus 1, so I replaced it. They told me Mw is 3x plus 3, so I replaced it. Then I used my algebra skills to solve for x. Once I knew x, I plugged it back into Vm and Mw to find out what their lengths really meant. 4x minus 1 is not a real length. If you went to the lumber yard and said, hey, I need 4x minus 1 feet of 2x4s, they're going to smack you with a 2x4. But if you say, hey, I need 15 feet of 2x4s, they know exactly what you're saying. 4x minus 1 is just the algebra behind the geometry. And I hate to tell you, you're not getting away from algebra in geometry. You have to use algebra to solve the geometry. The geometry of this segment right now is midpoints. That's the geometry aspect. The algebra aspect is solving for x to find out what the midpoints actually are. Now let's look at example 2. We're told to find the length of PQ. Well, what I want you to look at in this first part of example 2 is they gave me this hint. These two little dashes. In geometry, when two things are equal, we give them little dashes. Now, maybe they both have 2 dashes, or maybe they both have 3, whatever. As long as they have the same number, that's telling us they're equal. That's telling anyone in the world this segment and this segment are equal. If you notice up here, those segments had dashes on them, but you didn't know that just yet. Maybe you did. Maybe you're a genius. Maybe you should be teaching this class. Anyway, those 2 dashes tell us that they're equal. So we could set them equal to each other. Or, if I know one, I automatically know the other. If this segment and this segment, if PM and MQ are equal, well then if one of them is 1 7/8, I know the other is 1 7/8. Now I'm told to find the total distance. Well, that's like the segment addition postulate. So I can say that PM plus MQ equals PQ. And that's going to help me solve for PQ. Well, PM is 1 7/8. MQ is 1 7/8. And now I should be able to find out what PQ is. It's 2 14/8. Now that's not exactly accurate, but you get what I'm saying. 7 plus 7 is 14. What are we adding of? We're adding 7/8 and 7/8. That gives us 14/8. 1 plus 1 is 2. Well, now 14/8, if you divide that in your calculator, that's an improper fraction. The top number is bigger than the bottom number. So what we can do is we can take 8 out of it, add 1 over here, and we get 6 left over. So 2 14/8 is actually 3 6/8. Maybe you got really, really confused on that. Punch in your calculator 1 times 7 divided by 8 plus 1 times 7 divided by 8. Hit enter, and you'll get the same thing as 3 times 6 divided by 8. You'll get 3 6/8. Or just turn both of them into a decimal if you want. Either way, we use the segment addition postulate here. The same thing over here. I can see that these little tick marks excuse me, tell me that this segment, PM, is equal to this segment, or MQ. Now, because they're equal, or because those little tick marks, I can set them equal to each other, and now I can set their lengths equal to each other, like 5x minus 7 and 11 minus 2x. And because I set them equal to each other, now I can actually solve and find the length, just like I did in example 1. Well, I'm going to use my algebra, and I'm going to move this negative 2x to the other side by adding 2x to both sides. When I do that, I get 7x minus 7 equals 11. I'm going to add 7 to both sides. When I do that, I get 7x equals 18. Divide both sides by 7. And I get x equals 18 divided by 7 should be 2. I'm going to grab my calculator real quick. I don't want to give you a wrong answer. 18 divided by 7, 2.57, or just 2 4/7 left over. So if each x is 2 4/7, we can solve for PM and MQ. I can take 2 4/7. Oops. I can take 2 4/7, times it by 5, and then subtract 7. And I find out that this side is, let me use a different color, 5.85. This side is also 5.85. So PQ is 5.85 plus 5.85, or 11.7. Now, I know that that was a lot. I know that that was a lot of algebra too. You're going to find that your algebra has to be up to par. It has to be where it needs to be. If not, you're going to get left behind rather quickly. So make sure that when we're going through and solving these problems using algebra, make sure that if you have to, you pause the video and you actually do the steps with us. Make sure that you understand why. Make sure you understand that when we add 2x to both sides, it's so that the 2x's will cancel out and I'll have all my x's on one side. Make sure you understand that in the end, when we divide, we're getting rid of the 7's or whatever to get x by itself. Make sure you understand that. If your algebra isn't where it needs to be, then the geometry parts are going to get a little bit harder. So then we move forward into the midpoint formula. And the midpoint formula gives you the coordinate of the midpoint. It gives you the coordinate. It gives you the x value and the y value of the midpoint. So let's look at this. We're given a line segment here. We're given RS, where R is at 1, -3, and S is at 4, 2. Before I go any farther, I'm going to label R as x1, y1, and as S, x2, y2. You might say, well, why? Because R comes first when I read it left to right. That's all. Now you could go S as x1, y1, R as x2, y2. You'll get the same answer as us. But that's just the way I do it. So I'm told to find the midpoint. Now what I'm going to do is take my midpoint formula, x plus x divided by 2. I'm going to take my two x's, 4 and 1, divide it by 2. I take my two y's, -3 and 2, divide it by 2. It's a really ugly 2. Sorry, I didn't mean to insult the 2. It's really ugly. 4 plus 1 is 5 over 2. -3 plus 2 is -1 over 2. And so what I get is I get 2.5 because 5 divided by 2 is 2.5. And then -0.5 because -1 divided by 2 is -0.5. And so what I find here is that my midpoint is at 2.5, -0.5. My midpoint is right there. And notice it gave me the coordinate. It gave me the exact location in space of the midpoint. And we could label it P. I mean, it doesn't really matter. We bisected RS using the midpoint formula. You can use algebra, okay? Set one side equal to the other side and use your algebra to solve. Or you can use a geometry formula. A formula that was built to find the midpoint, find the coordinate of the midpoint. Let's look at another one, and this one's a little bit tougher. You might say, oh no, don't worry about it, you'll figure it out. We'll work through it together. We're told the midpoint of JK is point M, and point M is at 2, 1. The first thing I'm going to do is go label 2, 1. I'm going to label it M. I know that's the midpoint of my segment. I don't even know where my segment is, but I know that's the midpoint. If J is at 1, 4, so 1, 4, then where is K? Well, K has got to be down here somewhere. And there are a couple different ways that you could do it. If you're imaginative enough, you can say, well, I'll take this distance and go that distance more. And I'll let you think about that. There's another way to do it using the formula and using algebra. We can say the midpoint of our x's equals, whatever the midpoint was. And the midpoint of our y's equals, whatever that is. And we can actually use that information to solve for the missing point. They gave me J is 1, 4, so that's going to be my x1. Let me use a different color, excuse me. x1, y1. And my K is going to be my x2, y2, and that's what I'm looking for. So I'll plug in the J and the M, because the M and the M is the x and y as my answer. Remember that when you solve for a midpoint, you get an x and a y as your answer. If I plug in J for my x's, I got M for my y's, and so I can solve for my k's, I can solve for the missing pieces of k that got me to M. So let me replace this, and I know this is a lot, and this is a really tough problem. Don't worry about it. If you're kind of lost, just try and follow along. If I add the x's together, the x from the J that I had was 1. So 1 plus x divided by 2 equals the x from the M is 2. Then if I add the y's, the y from J is 4, plus whatever the x from the k was, divided by 2, and I got the, excuse me, the y, not the x's, the y from m, which is 1. So the formula for the midpoint, if I plug in everything that I know the coordinates of j, I know what I got as m, I can use that information to solve for the missing pieces, the x and the y that are missing, which will end up pointing me to k. Now I'm going to use my algebra. I'm going to multiply both sides by 2. When I do that, the 2's cancel out over here, and I'm left with 1 plus x equals 4, and 4 plus y equals 2. Now if I subtract whatever I'm adding to y and x, like 1 over there and 4 over here, I get x equals 4 minus 1, which is 3, y equals 2 minus 4, which is a negative 2. That tells me that the xy of k is at 3, negative 2. And so if I draw my line, I drew line segment JK, and M is indeed the midpoint. Now I know that that was a lot and that was really tough. Even the way I explained it was a little bit confusing. So don't worry if you kind of got lost on that. If you have a problem like that on tonight's homework, do your best and we'll go over it again when we check your homework. But that's the midpoint formula. The x plus x divided by 2 gives you the x coordinate. The y plus y divided by 2 gives you the y coordinate. The x and the y give you the exact position of the midpoint. Let's keep going. You have the distance formula. The distance formula. Now, if the midpoint tells you where the middle is, the distance formula tells you the distance of the whole segment. And if you notice, we have 2 points in each. x2 minus x1 squared plus y2 minus y1 squared. And then you find the square root of that. And that tells you the distance of your whole segment. For example, if I want to find the distance of RS, I'm going to go through this formula and I'm going to replace it with my x and y's from RS. Now I need to label these. I'm going to label R as x1, y1, S as x2, y2, and now I'll go through and instead of writing x2, I'm going to write what x2 equals, and that's 4, minus x1, which is 2, and that has to be squared, plus y2, which is negative 1, minus y1, which is 3, and that has to be squared. Now I'm going to go through and I'm going to simplify this. 4 minus 2 is 2. That still has to be squared. A negative 1 plus a negative 3 is a negative 4, and that needs to be squared. Now, hopefully you remember that squaring something means you're just multiplying it by itself twice. Okay? The 2 means it's happening twice. So 2 squared means 2 times 2, which is 4. Negative 4 squared. Whoa, I don't know what just happened there. Let's just erase that big boy. Negative 4 squared is like saying negative 4 times negative 4, which is 16. Gives us the square root of 20, and that's good enough for now. Eventually we'll learn how to solve that or break that down even further, but for now that's good enough. We know that RS, this little guy right here, is the square root of 20 as far as a distance. Now I want you to try and go through the distance formula with xy. First thing you should be doing is labeling x as x1, y1, y as x2, y2. Again, the only reason I do this is if I read this graph from left to right like a book, x comes first, that's why I labeled it x1, y1. Y comes second, so I labeled it x2, y2. You go through and practice putting these problems or these parts into the distance formula. Don't worry about solving it. Just replace all the variables with the values. I'll even get you started. You should have something minus something squared plus something minus something squared. Go through and replace those now. Pause the video, and then when you're done, hit play. Hopefully this is what your problem looks like. 6 minus a negative 6, because 6 was our x2, negative 6 was our y1, so we have 6 minus negative 6. And then, instead of y2 minus y1, we have negative 6 minus 5. Now we can simplify this. I can simplify 6 minus a negative 6. That's the same as saying 6 plus 6, which is 12. And that still needs to be squared. A negative 6 minus 5 is the same as a negative 6 plus a negative 5, which is negative 11. Still needs to be squared. Now, again, hopefully you remember that squaring something means multiply it by itself. So, 12 squared is 12 times 12, which is 144. Negative 11 squared is negative 11 times negative 11, which is 121. Now if I add these together, 144 plus 121 gives me 265, and again the square root of 265, so that's my answer. That's good enough. I don't need to break that down any further. I certainly don't want to punch it in my calculator and get some big old decimal. I know it's not a whole number, so I don't want to write the long decimal. That's a good enough answer. Why do more work than you have to? The distance formula is a very simple formula. It isn't something that you're going to have to remember in geometry or memorize, because I'm usually going to give it to you, especially on like your exams, your midterm, your final. You'll have the opportunity to write it down so that you don't have to memorize it. When you practice your homework tonight, you're going to be using the midpoint formula, which gives you your x plus x and your y plus y. And then you're also going to be using the distance formula, and then you're also going to be using your algebra to solve for missing pieces, like what we did in example 1, where you set two segments equal to each other, solve for the variable, put the variable back in, and find out what the pieces actually are. And that's it. I know that's a lot, and I know that this lesson took a long time, so let's go ahead and look at your homework now.